All right, 11.4, number 5, math induction, proving that this equals this. There's 2 steps to math induction to see if it's true for n equal to 1. So if I plug in 1 here, I get 1 cubed. Is that equal to 1 squared times 1 plus 1 squared over 4? So I end up getting 4 over 4, so 1 does equal 1, and we know it's true. Okay, so now we assume it to be true for n equal to 1. Now let's see if it's true for the next term, which would be n plus 1, but we can't use n plus 1 when we're proving it, so we'll just use in terms of k. So this one in terms of k will be k squared times k plus 1 squared over 4, plus this one in terms of k plus 1, so that's k plus 1 cubed, should equal this one in terms of k plus 1, so k plus 1 squared, k plus 1 plus 1, plus 1 squared over 4. So I basically have k plus 1 squared, k plus 2 squared over 4, or times 1/4 on the right side.
K plus 1 plus 1. Like, where did you get that from?
Because I put k plus 1 right there for n, so it's k plus 1 and then plus another one. Okay, so now the rest is just algebra. Where to start? Well, for me, I would recognize that I have a k plus 1 quantity squared and a k plus 1 cubed. Kind of like if I have 4x squared plus x cubed. What can I factor out of 4x squared and plus x cubed? I can pull out an x squared. Good. So I have a k plus 1 squared and a k plus 1 cubed. I can pull out a k plus 1 squared from each of those. So it'll be k plus 1 squared times, this is k squared over 4, plus I still have one more k plus 1. That's one way to do it. All right. So now, I don't know, I think since I'm looking over to the right, I have it divided by 4, so I can take out a 1/4 from this factor right here. If I pull out a 1/4, that'll be left with k squared plus 4k plus 4, and I took out a 1/4. If you can imagine, I pull out a 1/4 here, I have k squared. If I pull out a 1/4 from k, I'm left with 4k. And then if I pull a 1/4 out from 1, I have 4 left. Distribute the 1/4, and I'm going to have what I started. And now the only thing left to do is factor this trinomial, which is k plus 2 times k plus 2, or k plus 2 squared, and I'm still dividing by 4. Alright, so that's just one way of doing the algebra, and I mean it's solved or verified that equals that. Looking at this, most students would not recognize you could pull out a k plus 1 squared, so probably expand that, distribute the k squared. I don't know where that would take me. Maybe you kind of have to recognize they have a k plus 1 squared factor.
I was able to get it by expanding.
So you expanded it.
Yeah.
Did you expand this one too, Ethan?
I don't know.
Okay. So maybe I'll do it a different way.
At the end, I got k cubed plus 6k, k to the 4th plus 6k cubed plus 13k squared plus 12k plus 4.
Oh, you literally expanded both
Yeah.
sides. Yeah, that's the
Yeah.
most straightforward. That makes sense. Like if you don't know any of the algebra tricks, you could literally just, that's probably what you'd have to do. Because you probably still wouldn't recognize to pull out a k plus 1 even if you expand it. So you'd have to expand both sides and see if they equal each other. So that's quite the process.
It was.
So top here would be k squared plus 2k plus 1. I still have it divided by 4. Here, if binomial theorem, we could actually make this k cubed plus 3 k. Then you'd have to distribute the k squared, and I still have a 1/4. And then do the same thing with the other side. I'll call that good.